Alright, let's talk about the circle relation. Now, the circle relation does not look like a circle. It actually looks like Pythagoras' theorem. In fact, it is entirely based off Pythagoras' theorem, a squared plus b squared equals c squared, or c squared equals a squared plus b squared, except we have x squared plus y squared equals r squared. So basically, it's looking for all of the places in which this is true. Now, for some given radius. Now, let's have a look at it in Desmos just to give us a picture. Alrighty, so you can see here that for r equals 1, we get a circle with radius 1. So these are the 4 points where it hits at positive 1, 0, negative 1, 0 on the left, and then 0, 1 on the top, and 0, negative 1 on the bottom. And you can see that it is definitely a relation. It fails the vertical and the horizontal line test. But you can see as I change r, you can see that we can get different radiuses. So for example, if r is equal to 3, well, that means that we get a radius of 3. But notice, remember, in the formula, it's not r, it's equals r squared, which means that on the right-hand side is really 9, because that's 3 squared is 9. And you can see now, these are the points where it hits. So that's the basic idea of the circle relation. Now, the best way to sort of try to get a good understanding of why this is, and why it works, is by imagining drawing on a bunch of right-angled triangles. Well, it doesn't really matter where you draw the right-angled triangle, you'll always notice that the hypotenuse is just r. So basically all we're looking for is xy pairs where x squared plus y squared equals r squared. And so because r is fixed, it means that no matter how you draw x and y, it's always going to be the tip of this is always going to land on the edge of the circle. And that's how it fills in all of these points in a circular fashion. So it's very bizarre, this relationship between triangles and circles, but we're going to be seeing that this relationship does come up a little bit more, especially when we start looking at trigonometry. Doesn't matter. Where you draw your x and your y always gives us r as the hypotenuse. So with that, we can now start sketching them. So let's imagine we have x squared plus y squared equals 16. Well, 16 is really just 4 squared. So this is going to be circle with the center at the origin with radius 4. Basically meaning from the origin, you're going to go 4 to the right, 4 up, 4 down, and 4 to the left. So let's have a sketch. So to step 1, let's just draw ourselves the x and the y axes. Center of the circle is going to be at 0, 0. 4 to the right, 4 to the top. So this is 4, 0. This is 0, 4. Over here is going to be negative 4, 0. And down here is going to be 0, negative 4. And these are the 4 boundary points. And we can then just draw, as best we can, a continuous circle that goes all the way around this shape. And so this is x squared plus y squared equals 16. Now, interesting points, we can talk about domain and range. So for the domain of this function, well, it's certainly not infinite. We've got x has to be between negative 4 and 4. While for the range, we have that y has to be within negative 4 to 4. Notice this function does not go off into infinity in any directions. It is limited to just a circle of radius 4. So that's as far as it can go. So the x is from negative 4 to 4, while the y is from negative 4 to 4 as well. Now, we could obviously algebraically solve for the X-intercepts and Y-intercepts, but as you can see in this case, it's quite straightforward to just visually see. Well, if we've got a step 4 to the right because it's got a radius of 4, well, we can work out those points manually. Alrighty, I'll see you in the next one. Goodbye.